Alright, so welcome back. So this video is a continuation of this maximizing and minimizing. So I have done two videos, one which was on maximizing, the other one was on minimizing. So we have rectangles, and then we did the square prism, which you see right here. So in the previous video, we were given the volume and then we were trying to work with the surface area. So I'll put a link up above so that you can watch it if you like. So I'm going to take the same prism, so it's going to be a square prism here, and we're going to now assume the opposite. So we're going to assume that the surface area is given, so meaning we know what the surface of this prism is all the way around, and then top and bottom, and then we want to try to be able to maximize the volume itself. All right. So if it is a square prism, so the first thing that I'm going to do is, so that this depth D here is really going to be W. All right, so we have, in terms of volume, so the base is the width times the width in this case, because they're equal, because it's a square prism, so it's W squared, and then multiplied by the height. So that's our volume that we have, and we're going to try to maximize that. Now the surface area is provided here, and what the surface area is, okay, it is simply, so we're going to take the top and the bottom, so we have our top and bottom piece, so the bottom here and the top piece here, which is really just a square, so that's W squared because it's W times W. All right, so that's this bottom piece, and then this top piece right there, so if you have two of them, so that's 2W squared plus all the surface area around. So we're going to be plussing, so we have two of these, and then, okay, we have this kind of rectangular shape here where this is W and then this is your height, and we have four of these, right, because you're going all the way around. So that's where this has come from. Now, just for convenience, I'm going to just simply say area here instead of surface area, just so that I don't have to constantly put surface area as A. So when we were trying to kind of maximize and minimize in the previous videos, what I did was I used the trick of trying to simply take whatever is given. So in this case, our area is given, so we know what the area is, or what the surface area is. Then I isolated for one of the variables, and then I substituted it back into the other equation. So here what I'm going to do is I'm going to isolate for h, and then I'm going to substitute for h into this equation, and what that will do is it's going to get rid of h, and all I'm going to have is just w. Now once I do that, the goal is, again, we want to be able to maximize our volume. So I'm not going to use calculus here at all, because you can do it relatively simply with calculus once you kind of substitute and then isolate. So I'm assuming that you're in grade 9 and you're trying to work with these different prisms, and you maybe have come across. So I just want to show you how you can do this and then what will actually happen. Now I am going to think back, all right, to the maximizing the area of a rectangle. And if you remember that, so I'll put a video up above if you forgot. In that case, we noticed that if we wanted to maximize the area of a rectangle, it actually turned out that the sides had to be the same. All right. And here you're going to see exactly the same thing. So if you want to maximize the volume of this square prism, you will see that it will come out that all the sides are the same, meaning your width is going to equal your depth, it's going to equal your height. So if those three are the same, you actually have maximized the volume. So let's see how we can do that. I'm going to plot it for a few values so that you can see where the maximum volume would be. All right. So first, so the trick of just simply isolating, so I'm going to take A is equal to 2W squared plus 4WH, and I'm going to isolate here for my H. So first thing that I do is I'm going to shift this term over to the other side. So I'm going to get A minus 2W squared equals to 4WH. Now, because I'm isolating for that h right here, so I'm going to divide both sides by 4w, so like this, and that's going to give me what my h is. So the 4 cancels, the w cancels, and I have that h is equal to the surface area minus 2w squared divided by 4w. Now, it doesn't look very pretty, but that's okay. But now we have our h, which we wanted. And from here, what we're going to do is, because we want to be able to maximize the volume, we're going to take the volume equation, which is w squared, so that's the base, times h. But in this case, our h, all right, we have just substituted, okay, because we're going to use this, what we have isolated. So this is going to be a minus 2w squared all over 4w. Now, with a little bit of manipulation here, and maybe if you remember your exponents, okay, so notice that you have a w squared in front of the bracket, and then I have a 4w at the bottom. So this w right here can cancel one of these w's here. So instead of w squared, it's going to be just w, meaning this is going to be now w, all right, and this is a minus 2w squared all over our 4 here in the denominator. Now, if I bring this inside of the bracket, so I'm going to bring that inside right there, so I can just simply have a w minus 2w cubed, and the whole thing will be divided by 4. So that's my volume. So it's a little bit of manipulation. Not everybody likes it, but that's what we have. And now our goal is to try to maximize this volume. So we want to be able to find here what is the maximum value of w. Now, of course, w is going to be greater than 0, right? So that's what we need, because w can't be less than 0 because this is a prism, so it can't be negative. And also, there's going to be a maximum value for w as well. You know, you can't just keep increasing w forever because it has an impact on the height. And as you make w bigger and bigger, that prism basically, okay, it gets wider, but then it just starts shrinking in height. And eventually, if you make the w too big, it's going to flat, okay? It's going to go 0, all right? So we know that this w is going to be greater than 0, and it's going to be less than some maximum value, and we can see that. We can actually find it as well with a little bit of manipulation, all right? So now let's find out, and let's try to graph these volumes and see what happens. So we said, okay, as we started this video, that our area is given, so we know what this is. You can choose these arbitrarily. You can pick your favorite numbers for A, and then you're going to substitute. So I'm going to just substitute a few. Now, I am kind of teaching this to you, so I know in advance what kind of the best values for A would be, but you can pick any, and then we're going to see, because I'm going to graph this. Again, I'm not using calculus here. I just want to be able to graph it. So I'm going to pick a value for A, and then I'm going to graph it. Okay, so I'm going to use Desmos to graph it so that you can see what happens as W gets bigger and bigger and bigger. Okay, what happens to this volume? Initially, you'll see that the volume is going to go up, go up, go up, but eventually it's going to have a peak, and that's the maximum value. And then as we make W even bigger, then the volume is going to start to drop off. So I'm going to assume, all right, so let's assume that we have a few areas here. So for this, okay, so I'm going to say area, all right, so in the first area, I'm going to say we have 6, all right, that's my area. Then I'm going to say we have 24. Then I'm going to say we have 54. Now, you can keep going. Now, I'm choosing these kind of arbitrarily, but I know a little bit in advance, okay, what these will yield, okay? But you could just simply say area equals 1, 2, 3, 4, 5, 6, and you just can keep putting them in and then plotting them. So here what we want to see is we want to be able to see, okay, so what will happen to the volume? What's the maximum, okay, volume that we will get by setting this A, and then we want to find out what happens to W. All right, so let me plot this. Okay, so I'm going to plot this out for us. All right, so here is, again, so it's AW minus 2W cubed divided by 4. So you can plot it by yourself, taking a graph piece of paper and then just keep doing that. Now I'm going to use Desmos here, are my favorite kind of one of the tools. Okay, so to plot this out. So we want to have volume equals, all right. Now, okay, so let's not forget. So all I'm doing is I'm just taking this. So the area times W, okay, minus 2W cubed. So now my area, my first area, I'm going to put this in brackets. So 6W minus, okay, and this was 2W cubed, if I remember correctly there. And then it was divided by, so divided by 4. All right, so this is what we had. So let's double check. So, yep, so the area, I'm choosing this area right here. So 6, this is going to be my first value. Then W minus 2W cubed over 4. And what I notice, so I'm going to kind of zoom in here. So if you notice here, indeed, so this is the plot of the volume. And, okay, so if you take a look and peek here, on the vertical axis, that's your volume. So notice as W, so W is on the horizontal axis. So initially when it's 0, then there is no volume, because if there is no width, right, we don't have a volume at all. And then as the W gets bigger, notice that the volume keeps increasing. And then it peaks. It looks like it's peaking at 1. Now notice that at that value, W was equal to 1. All right, so I'm going to put that in here. So what we have, so I'm going to do something like this. I'm going to extend this out a little bit further. So this was V. So our maximum peak, it seems like it was 1. And this happened at W of 1. So that's what happened here. Okay, now I'm going to switch that area. I'm going to put 24. So if I put 24, so I'm going to go in here and kind of jiggle this around. So my area is 24 instead of 6. So now notice it's going to get a little bit bigger, but it looks kind of the same, right? So notice again, so as we move to the left on the W, now eventually notice that it will stop, right? Negative values for volume do not make any sense. So our W has to here be between 0, okay, and then some value as we can see there on the right-hand side, and then it just peaks down. So now notice that the volume peaked at 8. Right? So we can see it that it has peaked at 8, and that happened at W equals to 2. All right, so that means it peaked at 8, and that was at the value of 2. Now let's do one more. Okay, I'm going to substitute 54. So here, so if I put in 54 instead of 24, so 54, so it's going to get even bigger, so bigger volume. All right, because we'll have a bigger surface area. So now all of a sudden, so notice I'm going to stretch this out. So take a look at here. So our peak, okay, so our peak there all the way, so I just kind of plotted it up there. Notice that the peak is at 27, meaning volume is 27. And that happens when our W is at 3. That is our peak maximum. So here, if I put this in here, so this is 27 and this is 3. Now, as you may recall, what I was saying is that for rectangles, right? So the video that I kind of pointed out, if you wanted to go back there, to maximize the area of a rectangle, you know, the sides had to be the same. And then I said, well, I wonder if the volume, if we wanted to maximize a volume of a square prism, if, okay, basically all sides, including the height, would have to be the same. And indeed, this is actually what you're seeing. So notice that if you took, okay, so volume, our equation for volume, so volume is equal to W2H. So now, if we had, when we peaked at 1, Okay, so there for surface area was equal to 6. So for this value right here. So if we had surface area of 6, our volume was 1 and our W was 1. So here, if you're going to solve for H, well, 1 squared is just 1. So you notice that, hey, wait a minute, H is equal to 1. And that indeed, so my H, I'm going to do a chart here like that. So indeed, notice they are all the same. Now, if I'm going to take the volume of peak at 8, I can do the same thing here. So if I substitute that, so I'll do that on the left-hand side. So if my volume is 8, my width was 2, which is squared. And then if I solve this for H, so this is going to be 4, 8H, right, divided by 4 on both sides. And hey, voila, this is equal to 2. So I have now H is equal to 2, and that's exactly what happens. So all of them are the same. And you can try this for 3, and you're going to get exactly the same thing. So indeed, it is true that if you want to maximize the volume of a square prism, okay, all the sides are going to be the same. All right? So thanks for watching the video. We'll see you in a future one. Okay? Take care, everyone. Bye.